we're about to jump into some atoms. All right, so you guys probably heard of atoms before, but before we go down this route, first off, we got to give a shout out to John Dalton. Okay, so John Dalton is the person who proposed this atomic theory, and he actually proposed this back in 1808. Now, I'm just going to highlight 5 things from this theory, okay, that you guys are going to need to know. All right, so the first thing in this theory that he proposed, he basically said that each element is composed of tiny, 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 tiny little microscopic, little bitty, itsy bitsy witsy little, you know what I'm saying, indestructible atoms. Okay, so these are the first thing he said is each element will have tiny atoms. That's the very first thing. Okay, so the first thing we want to understand, all elements have these tiny atoms. Second point, all atoms of a given element are the same, but different from atoms of other elements. So basically this means, right, if I got carbon once again is an element, going back to that first thing we mentioned here. So we know that this element is going to have atoms. Number 2 is telling me that, well, carbon atoms will be different from oxygen atoms, right? Because it's a different element. So oxygen atoms are different from carbon atoms. This number 2. Number 3, atoms combine in simple whole number ratios to form compounds. All right. So we kind of mentioned it with the different laws as we mentioned before, but basically, right, when atoms come together, we're going to get a whole number ratio whenever we're forming a compound. So this goes later on. We're going to get to this when we're like looking at equations. But basically, right, you're not going to ever see any decimals or any fractions for a compound. All right, we'll get there with equations. But for now, just understand that we only have whole numbers when it comes to compounds. Only whole numbers. Right? You can't have half of a compound. You can only have whole of a compound. Now, let's look at 4. Atoms of one element can't change into another element. Now, this one was kind of big, low-key. So it's basically saying, right, we're not going to have any transmutation. Is that the right word? Man, anybody look at Full Metal? All right, so yeah, you can't have any of that going on here, right? You're not able to transform, all right, those atoms of that element into another element, right? So unfortunately, right, we're not able to take iron and transform that into gold. That's just not going to work. It's just impossible. All right, at least right now, or at least in my knowledge, you really don't ever know. But with John Dalton and his atomic theory that has been very true for a very, very long time, atoms of one element cannot be changed into another element. So we can't do any alchemy right here. Now, number 5, in chemical reactions, the atoms don't change, but the way they are bound together does. And this is the key thing, right? So number 5 is really getting into reactions. But basically, right, as we mentioned number 4, we're not able to change atoms to another element. We cannot do that. However, the only thing that can change, right, is the way that they're bound together. So when we're looking at like compounds and the way that they're bound to each other by bringing in those different elements, right, during this chemical reaction can change, right, the way that these things are bound. So basically, we can have different elements breaking apart and forming new compounds. And this is what we see in chemical reactions, right? Those atoms are not changing, as we know in number 4, but the way that they are bound to things are changing. And that's okay. That makes sense. All right, that can happen. So these are just some things that I wanted to point out with John Dalton. All right, he's the guy that came up with this atomic theory back in 1808. This guy was super smart.